guys, and welcome to another review video for math. Today we're going to be going over a statistics standard, which is dot plots. We're going to be going over how we create them. We're going to also be going over how we read them, and we're going to be going through a few terms that you need to know when we're talking about dot plots, and we'll get into those kind of definitions and those terms in a little bit. First thing I want to talk about, though, are what are dot plots, what do we use them for, and then how do we go about actually creating one of these things. So if you look at my board here, right, I have an example of a dot plot up here. It's very lackadaisical, I guess is a good word, example of a dot plot, just so you see what they kind of look like, right, where we have these numbers on the bottom, this line, and then all these dots that represent something, right, and we're going to talk about that something in a little bit. So the first thing I want to talk about, though, is how we create these things and what are they. So dot plots are a form of organizing statistical data, right? And there are some positives to it, and there are also some negatives to it, but we're going to really focus on the positives today. So what we need to first think about is, well, how do we create this thing, right? And if I have all of this sets of data, right, I have all of these numbers here, and I want to organize them and make them into a dot plot. So the first step you need to do when creating a dot plot is you need to order these guys from least to greatest. Like we always say with data, you always want the data in order from least to greatest because it's so much easier to pull out specific information if we do that. So if I ordered these guys in order, and again, how you do that is totally up to you. I like to use something called the cross-out method, which is where I write a number and then I'll cross it out to know, hey, I worked with that number already. So my lowest number here, or my minimum value here, I see would be 2. Right, so I'm just going to write 2, cross that guy out. Then I have a 3, cross him out. Do I have any more 3s? I do not. So let's move to 4. No other 4s. I see no 5s. I see some 6s. I have 1, 2, so I'm going to cross them out as I count them. 1, 2, 3, 4 6s. 1, 2, 3, 4 6s. I have 1, 2, 2 7s. I have 2 8s. I have 1 9. And then I have these 2 large guys. I have a 19 and I have a 22. So we know 19 and 22. So what I like to do after I rewrite them and after I put them in order from least to greatest, is just to count out the total number of data points I have, because you want to make sure you're not missing one, right? So in my original data set, I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14, 14, they equal each other. That means I got all my data points. So I did step 1. Step 1 is to take all those guys and order them from least to greatest. So I did that already. Step 2 would be to now draw this line, which I've already drawn in for you. So you would draw a straight line like this, because this is what all dot plots look like. You're going to draw a straight line like that. And you're going to need to include what we call the minimum value and the maximum value. So these are words you guys might have heard before. But, throw markers all over my room. So the minimum value is our smallest value, right? Which would be the guy all the way to the left on our number line. Because remember, as we move left on the number line, our numbers get smaller. And then our maximum value would be this guy all the way over here. Right? And if I look, in this case, now that I have them in order from least to greatest, well, it's really easy for me to find my minimum and maximum. Right? My minimum is going to be the number that's way over here on the left. And this guy, all the way on the right, would be my maximum, right? So I know here that my number line has to include a 2 and has to include this 22. Now, the common error a lot of people make after that is now they just look at all their numbers and they start plotting these guys down here, like, meaning they would be like 3, 4, 6, 7, 8, 9, 19. I'd be like, okay, I'm going to graph. Can't do that. Remember, this is a number line. And if I had my eraser, which I don't know where it is right at this minute. Look, I got it. So this you can't do, right? Because on a number line, we go up by something called a scale, meaning it goes up evenly. If every number you're going up by 1, that means every number you need to go up by 1, right? So what you need to determine is what scale can I go by to make sure I get all of these numbers in it at an even rate, at an even scale. So looking at this, my minimum is 2, my max is 22, I have 3s, I have 9s, they're not even numbers, it would be hard. So I'm just going to go up by 1s. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 20, 19, 18. Now, that's completely freehand. You see I completely did that freehand. It's okay if it doesn't look like each number is spread out the same amount. That's totally fine, as long as you're going up by that even scale. Okay? So you've done that. You've got your scale, you've got your minimum maximum, you've got your data in order. Your third step is now you're going to draw a dot for each of these data values. Now it can be a dot, it can be an X. We tend to just stick with dots and X's because those are the two symbols you're going to most of the time see on dot plots. So if I look at my data here, I'm going to get a different color now, I'll get pink. Okay. So if I look at my data here, I'm going to mark an X on this dot plot, or actually, yeah, I'll do an X. On this dot plot, every time I see a number. So I see 2, so I'm going to mark an X on my 2. I see a 3. I see a 4. I see 4 6s, so I'm going to stack them. This is what we call stacking, right? You go on top. You don't keep plotting next to it. You stack up. Okay, so 4 6s. I see 2 7s. I see 2 8s. I see a 9. I see a 19. And I see a 22. Okay, so now I've taken all that data and I've plotted it. I've plotted an X at every single value that has a point here, right? You see, I have all of these numbers with no X's on top of it. Well, it's because I have no data at that value, right? We see no 10s or we see no 15s in our original data. So we don't plot it. That's why it's empty. Okay, we're going to talk about what each of these guys kind of are called on a dot plot. We'll get to that in a second. The last and final step that you need to do is you need to title this guy. Okay, so usually when you're given a dot plot problem to go ahead and graph, there's usually some kind of question that goes with it or story that goes with it. So, for example, let's say that these were all points scored in a basketball game. Okay? So what you would need to do is now you'd have to title this guy, and it's okay if you title it down here or up here. I just have the space up here, so I'm going to title it as points scored by players in a basketball game. Right? So you need to have that title, because if I didn't have that title, this would just look like a number line with a bunch of X's on it, and we would have no idea what this represents. What is this? Why? What is this? What am I looking at? Right? That's why we need to have that title in there. And that's kind of how you create a dot plot. So now moving into our next thing with dot plots, well, now we're going to look at, well, what exactly can we pull from dot plots? Why do we need to know these terms, and what does this help us determine when we're looking at dot plots? So we're going to go through each of these. I'm going to explain what each of them are, and then we'll find out the answer using that dot plot next to it. So our first term is the number of observations. Okay, and I'm sure a lot of you have heard of the word observations from science or something. Basically, it's the number of times something has happened. Right? So if I look at my dot plot, basically what number of observations means how many dots are there? How many X's are there? And that's simply it. So if I look at my dot plot here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 19 observations, right? Or I have 19 x's. That's all the number of observations is. It's simply just counting up how many dots or x's do you see on the graph. Your minimum, we talked about that a little bit earlier, right? Your minimum is your smallest value. What is the smallest number where you have data, right? So looking here, where's the smallest number I have an x? Well, that would be 10. My maximum, and this is where we see some common errors happening, right? Our maximum, well, if you look at my number line, we know the maximum means the highest number. So a lot of us would just jump right to 20 and go, oh, well, that's my maximum because that's the highest number I see on my graph. But notice, do we have any data at 20? Do we see an x above 20? We don't. So since we don't see an x there, we don't count that as a data value. We don't count that as the maximum. We need that number to have some data in it in order to say that it's the maximum. So in this case, it would be 19 because we have the x above 19. So our maximum here would be 19. Your range. What your range really is, it's your minimum. Oh, sorry. Nope. Look at me. It's your maximum minus your minimum. So you're just taking those two numbers and you're subtracting them. So your range for this would be 19 minus 10, which is 9. That would be your range. Okay, your range wouldn't be 19 minus 10. No, your range is one number. So it would be 9. You have to actually do the math. You can't just leave it 19 minus 10. Okay? Interval. So there's no real interval here that I'm asking you about. I just wanted to talk about that word a little bit, what interval means. So interval basically is when you take two of your points on your number line here. So like, for example, if I was to ask you, how many students visited states in the interval of 10 to 12? The interval of 10 to 12. Well, the interval means, well, I'm looking at from just 10 to 12. So I would have, what, 3, 8, and 6 more, which is 14. So I would have 14 students in that interval. Okay, so the interval is basically taking two numbers in your data and saying, well, how much are between those two numbers, including those numbers, right? So the interval of 10 to 12 would just be this data. If I said the interval of 15 to 17, how many students went to 15 to 17 states in that interval? Well, we have no data there, so there would be 0 students. Okay, so just think of interval as kind of like sections of your dot plot, right? We have, and intervals could be as big as you want. Intervals could be two numbers. It could be 10 to 11. It could be the interval of 10 to 1,000, right? It doesn't matter. But interval is just speaking about a specific section of your graph, okay? Cluster. So I'm sure we've all heard of the word cluster, right? We're in a mall and it's really, really, really crowded. It's Christmas time and or Hanukkah time and you're buying gifts for the holidays and it is just so crowded you feel like you're in a huge cluster, right? There's a whole bunch of things happening. So that is exactly what cluster means here too. It's where on our graph is there a whole bunch of data values. So in this instance, we have a whole bunch of data on our graph here, right? When we have this little guy out here. So this is where a cluster of our data is. So our cluster, this you write in interval form. So in this one you would write, your cluster is from 10 to 14. Okay? And when you talk about clusters, you always want to go, I know 14 only has one data point there, but your cluster should always start and end where there's data, right? You can't say your cluster is 10 to 13 because 14 still has data there, so that needs to be included in your cluster, okay? So our cluster is 10 to 14. Your mode, we know what mode is, right? Mean, median, mode. Mode is the most often. Where on our dot plot do we have the most data? So in this instance, most of our data here is at 12, so that would be our mode. And just remember, you can have more than one mode. You can have 5 modes, you can have 10 modes. Okay, if let's say 13 had the same amount as 12, well, 12 and 13 would be your mode. It's at what data value or values is there the most data happening. Okay? Gap. We all know what a gap is, right? A gap is a huge space of nothingness, right? If you ever, I don't know, you play sports or you ride a bike and you need to jump a gap, right? That means you need to jump a spot where there's nothing, right? Jump over a spot where there's nothing. Well, that's what a gap is here too. It's where in our dot plot is there nothing happening. So in this instance, I have a gap here from 15 to 18. From 15 to 18, I have no data happening. It would not be 14 to 19, even though you might think that, right? Because we have our gap here. "14 has data on it. 19 has data on it. They're not part of the gap, right? A gap means you have absolutely nothing. So I can't say 14 is part of that because it has data there. Okay? So our gap would let me just erase this. So remember, our gap would start and end where there's no data at all. Okay? It doesn't go to where those X's are. Okay? So our gap is there from 15 to 18. And then our outlier. Right? And let me just, on here, just to kind of give you a reference. Right, remember we called these guys cluster. Okay. The last one we're going to talk about is our outlier. And an outlier, if you ever heard that term before, an outlier means something that is much different from the rest. Right? If you think of it in terms of sports, right? People would say Michael Jordan or LeBron James are an outlier because they're just so much better than a lot of NBA players that have been. Right? So they're an outlier. So that outlier means he is so far away or distant from the rest. So in this problem, we see we have this X kind of lonely out here at 19. So this guy, oh, you can't really see that color, would be our outlier. Oh, I spelled that wrong. Outlier. Alright, so when you answer it here, your outlier would be 19. Okay, so there is a lot of terminology that goes along with dot plots. Okay, but it's all stuff that you can kind of relate to it, and you understand what, if you understand what the term is, it's really easy to find. Right? Number of observations, how many X's. Your minimum, what's your lowest number where you have a data value? Maximum, where's your highest number you have a data value? Your range, what is your maximum minus your minimum? Your cluster, where do we see a whole bunch of data happening? Your mode, where is it happening the most? What is the highest number? What is the highest amount of data? What number? Your gap, where is there nothing happening? And then your outlier, which guy is way away from the rest of us. And that's kind of what we use dot plots for, and how and all the information we're able to easily pull from dot plots. Hope this helps. If you guys have any questions or anything, comment below. We'll see you next time. Bye, guys.